compound events, and this is where we are still just, like we did in the last lesson, rolling a die one time. We're just doing one particular thing, but where multiple outcomes are okay for us. So we are going to be concerned with events that are called mutually exclusive events. Mutually exclusive events means there's no way that both of those things can happen at the same time. So like rain, for example. It is either raining or it is not raining. It might be raining lightly, but even if it's just drizzling, it is still raining. So that would be a mutually exclusive event. It's either doing it or it's not. Okay? A card is either red or it is not. Okay? There's no in-between there. Those would be considered mutually exclusive. There's no way that it can happen and not happen. Sometimes other things, both of them can be happening. It can be raining and sunny. Or it can be raining and not sunny. Okay? Just because one of those things happen, it doesn't have any effect necessarily on the other one. So there are a couple of formulas here. I'm not much of a formula person in terms of my probability problems, but there are a couple of formulas here that talk about the probability of compound events. When it says is if they're mutually exclusive, the second formula says we can just add together the individual probabilities. So if there's no way that both of those things could happen, we can just say what's the probability of the one thing and then add to it the probability of the other thing. But the first formula says if there's some sort of chance that both of those things could be happening, then we need to subtract out that overlap of both things occurring at the same time. Randomly selected from our 52 card deck, what is the probability that it is an ace or a face card? So I'm still just drawing one card. What is the probability that I have an ace? Well, how many aces are there? 4 out of the 52 cards. When we say or in a probability problem, that means we are adding. So I want to add to that a face card. How many face cards are there? 12. Jacks, queens, and kings of the 4 different suits. So there are 12 of those out of the 52 cards. Then what we need to do is say, did I accidentally count the same card in both of those groups? So are there any aces that also have faces on them? No, because face cards are kings, queens, and jacks, which are different than aces. So there's no overlap there. Every card was only counted one time. So we can add those together and get 16 out of 52. So these two events are mutually exclusive. There's no way that I could pick out one card that meets both of the criteria. It can't be an ace and a face card. So these are mutually exclusive events. We always want to reduce our final answers. Those both reduce by 4 to give 4 out of 13. One die is rolled. What is the probability of rolling a multiple of 3 or 5? So multiple of 3, how many multiples of 3 are there on a die? 2. There's the 3 and the 6. Out of the 6 sides on the die. Or means we add. There's only one 5 on the die out of the 6 sides. Did we count any side of that die twice? No. The first one was just the 3 and the 6. The next one was the 5. So we didn't double up at all. So we can just add these together and say 3 out of 6, or 1/2 of the possibilities are good possibilities. So these also were mutually exclusive events. There's no way that the number I roll could be both a multiple of 3 and a 5. It doesn't work. Questions? What is the probability that the card is a heart or a face card? How many hearts are there?
4. Wait, no. 13.
13 hearts. It's one of the suits. So there are 13 cards that have hearts on them out of the 52. Or, so we're going to add to that a face card. How many face cards are there? 12 out of the 52. Are there any cards that meet both of those criteria, that have a heart and a face on them?
Yes.
How many? 3. The jack, the queen, and the king of hearts meet both of those criteria. So we need to subtract that out because we accidentally counted it in both groups. So we need to subtract out those 3 cards that we counted twice. So this is not a mutually exclusive problem because it is possible that a card can be both a heart and have a face on it. So these are not mutually exclusive. So then we can add together, get 25 minus 3 is 22 then out of 52, or 11 out of 26. For those of you who are visual learners, this can also be represented by a Venn diagram. So in one of my circles, we'll go that could happen, which would be a heart, and in the other one, the other possibility, which would be a face. There are 13 hearts, and there are 12 faces. How many have both? Heart and face. 3. That's going to go in our overlap. That fits in both of the circles. So that means the cards that have the heart but no face are 10. So that whole circle still adds up to 13. And the ones that have a face but not a heart are 9. So that whole circle still adds up to 12. And if I add that up across the middle, 10 plus 3 plus 9, I get the 22 out of the 52 that we got before. So it's a visual way to represent the same thing that's happening here. The next question, we're rolling a die again. What's the probability of rolling a multiple of 3? Well, how many multiples are there? 2. Or, so we add a multiple of 2. How many of those are there? 2, 6, so there's 3 of those. Did you count the roll twice? Which one? 6. 6 meets both of those. 1/6 because we counted that one roll of a 6 twice. So that means 4 of the 6 options are good, or 2/3 of a chance of that happening. Questions? Last year, a company paid overtime wages or hired temp help for 9 months. We have our keyword "or" there. And that goes with the 9 months. Overtime happened during 7 months, and temp help during 4 months. At the end of the year, an auditor examines the accounting records, randomly selects 1 month to check the payroll. What is the probability the auditor will select a month in which the company paid overtime and hired temp help? So we have another keyword for it. I like to represent these with Venn diagrams. It's not necessary, but it's just organize all this information because there's a lot of information in this problem. So I'm going to let one circle be overtime, one circle be temp help. How many months did they do overtime? 7. Okay, it says overtime wages were paid during 7 months. How many did they do temp help? 4. So what's that 9? That's the or, right? And what does or mean? Or comes from adding. So or would come from adding up across the middle, and we should get 9. But if I add up 7 and 4, I don't get 9. I get 11, which means there must have been a couple of months that they did both of the things. So since when I add up the 7 and the 4, I get 11 and not 9. That extra of 2 must mean that both things were occurring in those months. So there were 5 months that they just did overtime. And there were 2 months that they just did temp. And 2 months where they did both. So adding it all together gives 9 months where they were doing something extra. Okay. Now the question is then, at the end, now that we've organized all this information, the auditor is going to select 1 month randomly to select the payroll. What is the probability that the auditor is going to select a month in which overtime and temp help occurred? So how many months were there overtime and temp help? 2. And is the overlap. Or is what you get when you add up across the middle. And is the overlap. So there are 2 months that both of those things were occurring. Out of how many months could the auditor choose to look at? This is kind of a trick question.
11.
It's 9.
12. He could pick any month of the year. If it was me, I would be like crossing my fingers that I would pick one of the months where nothing extra was happening, because that would be easy to check payroll then. Whereas if you've got overtime, you got to make sure the time and a half is happening right, and if there's temp help, there's extra paychecks going out. So there's a 2-month chance that there's a whole lot of craziness going on. But there were some months where nothing extra was happening, whatever their slow time of the year is for this particular company. So he could pick from any of the 12 months, like is a 2 out of 12 or a 1 out of 6 chance. Okay. Same type of question. So I would like you to give a try to problem number 6, creating a Venn diagram and trying to answer the final probability question. So I'm going to start by making a Venn diagram. One of the circles is going to represent French, and the other circle is going to represent math. We are told that 6 out of 15 took French, and 11 out of 15 took math. 14 out of 15 took French or math, and or comes from adding up all the individual values. But if I add up the 6 and the 11, I get more than 14. By how much? 3. So that means 3 kids must have been enrolled in French and math. There were 3 that were just in French and 8 that were just in math.
How did you get 14?
It tells us 14 out of 15 took French or math. And or is the adding across the middle. Okay, so what does that mean about the other kid? They didn't take math or French, so in terms of the Venn diagram, they're just kind of floating over here. There's one kid that's not taking French or math. I don't know, I guess all science and Spanish and English. I don't know how you can get away with not doing that, but clearly at this school that's okay. So altogether, 15 kids were surveyed. 14 of them took at least French or math. Some of them, 3 of them in fact, took both. So the question then asks, what is the probability the student took French and math? And so there are 3 of them out of all 15 that were surveyed. So 1/5 when we reduce that down. Questions? Yes.
You have to do each of the both,
Yes.
but 11 plus 6 adds up to 17, so
Yes.
that would be 2.
No, 14 is what it should add up to, because 14 is our or value.
Oh,
14 took French or math.
okay.
All right, the next piece of note says an event, A, and then it uses a little apostrophe. That symbol we read in math as a prime. When we use an apostrophe in math, we read it as prime. A prime is the complement of an event, which is the opposite of it happening. So you already are pretty aware with this idea in terms of maybe weather. If there's a 30% chance it is going to rain, then what is the chance it is not going to rain? 70. Those are mutually exclusive events. It either happens or it doesn't. So we can take the complement by saying 1 minus the probability of something happening is the probability of it not happening. This only works for mutually exclusive events. If there's a possibility that it could happen and not happen, this doesn't work then. These have to be opposite events. In your packet, you have a chart of the 36 possibilities of when 2 dice are rolled. It's on the same page as where the sample of the deck of cards is. It's considered to be 36 different options because we say that rolling a 1 and a 2 is different than rolling a 2 and a 1. Because if one of the die were green and one of the dice were red, then we would be able to tell a difference between a 1 and a 2 or 1. So there are 36 different things that can happen when we roll 2 dice. Question A says, find the probability the sum is not 8. There are 2 ways to do this question. One is to look through this whole diagram and find all of them that add up to something other than 8. Okay? We could do that. But it seems like there's a lot of things here that are going to add up to something other than 8. So a quicker way about this problem would be to do 1 minus the probability that the sum is 8. Because there probably aren't that many ways to roll and get an 8. And since it's either an 8 or not an 8, these are mutually exclusive events. So that's the way I'm going to work the problem, is looking through this table and trying to find all the ways that I could roll and get an 8. I could get a 2 and a 6, a 3 and a 5, 2. Conveniently in this chart, the equal on the diagonals. So they should be kind of easy to spot. Once you find one, you can just kind of follow the diagonals. So there are 5 ways that we could get an 8 when we roll 2 dice. So the probability of getting an 8 is 5 out of 36. So the probability of not getting an 8 would be what happens when we subtract that from 1, or with a common denominator, 36 out of 36. So that leaves 31 out of 36 ways to get something other than an 8. Question B. The sum is greater than or equal to 4. Well, it seems like there's a lot of ways to get something greater than or equal to 4. So we could do that. We could go through and find everything that meets that criteria. Or we could do 1 minus the opposite. What is the opposite of greater than or equal? Less than. Because equal to is already accounted for. So greater than or equal to takes that 4 and everything bigger. We want just the opposite, which would be just strictly less than 4. So the stuff that adds up to less than 4, well, 1 plus 1 is less than 4. 1 plus 2 is less than 4. As I keep reading across, 1 plus 3 is 4, so I don't want to include that. So then drop down to the next row, 2 plus 1. And everything else in this table is at least 4 or bigger. So there are only 3 ways out of the 36 to get something smaller than 4. Subtract that from 1, and we get 33 out of 36. Or reduce that, 11 out of 12. Okay, you will have some of these in your homework, so using that chart that's in your packet will be helpful to you there. Questions? Probability that the card is not a king. So when we have that word not, I'm going to think about the consonants here. Instead of finding the probability of not a king, I'm going to say 1 minus the probability of a king. So how many kings are there? 4 out of the 52. And then everything else should not be a king. So I can subtract that from 1, or 52 out of 52, which gives 48 out of 52, which reduces to 12 out of 13. So when I have that word not in a problem, that's when I'm going to definitely want to go with the complement. The card is not an ace or a jack, so I'm going to do 1 minus the probability of ace or jack. So how many aces are there? 4. How many jacks are there? 4, and or means I'm going to add. Then, when we're considering two different criteria, we always need to ask ourselves, did I double count? Is there something that has both an ace and a jack on it? No. So in this case, we don't need to subtract anything out. But whenever you're looking at two different options, you should always consider the possibility that you've counted the same card in both of those groups. So I'm going to do 52 out of 52. So that gives 52 out of 52 minus 8 out of 52, which leaves 44 out of 52, or 11 out of 13. Questions? I want to show you how the first group of your homework problems are set up so that you know how to deal with the notation there. So I'm not going to do your first homework problem, but I'll do one like it. So it says, in the problem that I'm choosing, probability of A is 0.4. Probability of B is 0.35. Probability of A or B is 0.5. And the probability of A and B is blank. I like to represent these by Venn diagrams. You don't have to. You could use the formula in your notes as well, but I'm not much of a formula person. So I like to use Venn diagrams, and I'm going to say I have my A circle and B circle. The A circle should have it, and the B circle should have 0.35 in it. Or comes from adding. So if I add, it should add up to 0.5. But if I add up what A and B are individually, what do I get? 0.75, which is a problem because it's supposed to add up to 0.5. So what does that mean? There's some overlap. So we're going to subtract out what it's supposed to add up to, and that means that 0.25 is the overlap. Overlap is and, so that is our answer here. We could also, we don't need to for this particular problem, but for others you might need to figure out what's in the individual circles. So the probability of just A happening is 0.15 subtracting out, and the probability of just B happening is 0.1 from subtracting out. Okay.
So to get those answers, you would minus 0.25.
Yep, I take the top value and subtract out circle. These questions also ask, are these two events mutually exclusive? So in this problem, mutually exclusive. No. How can you tell? What does it mean to be mutually exclusive? They can't both be happening, and in this problem, can they both happen? Yeah, there's a 0.25 chance that both of those things are occurring. So these are not mutually exclusive. So 2 answers for that first group of questions. You need to find your fill-in-the-blank number for which one of the probabilities you're asking, and then also determine if they are mutually exclusive. If there is a value other than 0 in that overlap, they are not mutually exclusive.